Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli, the Computer Guy, and in today's class, we're going to be doing a brief introduction to the Raspberry Pi. So the Raspberry Pi is cool. The Raspberry Pi is sexy. For the IoT world and the IT infrastructure, the Raspberry Pi is absolutely an amazing thing. But just like many IT products, if you don't understand what the Raspberry Pi actually is, you are going to lose your mind trying to deploy this into the real world. One of the big issues with people that try to go when they try to start using Raspberry Pis is they fundamentally do not understand what this product is. So when they go and try to develop solutions based off the product, or when they go out and actually try to deploy this into the real world, all hell ensues because it's just not what they thought it was, right? So basically today's class, we're going to go over what a Raspberry Pi actually is and give you a decent introduction so you feel comfortable going forward to develop projects with your Raspberry Pi. So the first thing to talk about when we start talking about the Raspberry Pi is to explain what the Raspberry Pi is not. Again, one of the big issues in the technology world is people assume a product does something that it doesn't do, and then they spend the next month ripping their hair out trying to get the product to do what it's never going to do. So it's very important to understand what the Raspberry Pi is not, so then you don't try to start developing things that you're just never going to get to work on the Raspberry Pi. So we look at the three different products that I have on the table here. You might look at these three products and go, oh, these are the same things, right? You know, we're talking about the IoT world. I have a Raspberry Pi here, I have a mini PC here, and I have an Arduino here. Some people at home may be looking at this going, okay, those are the same types of things. Let's move on. The important thing to understand is these are not the same types of products. These are incredibly different, and you will use them in different situations. A Raspberry Pi is a Raspberry Pi. A mini PC is a mini PC, and an Arduino is off in its own little world entirely. So when we're talking about a Raspberry Pi, the important thing to understand is that this is in fact a full-fledged computer. This has a real CPU, this has RAM, this has storage, it has the normal input and outputs, so it has USB, it has a network card, depending on what version you purchase. It has a network card, again, depending on what version you purchase. It has a Wi-Fi, standard Wi-Fi, Bluetooth, the whole 9 yards. So what I can do is I can actually install an operating system onto this Raspberry Pi, connect it to a monitor, connect it to a keyboard and mouse, connect it to the network, and basically when I boot it up, you will be in a very normal operating system environment. So there are a lot of different operating systems you can run on a Raspberry Pi. There are variations of Windows you can run on a Raspberry Pi. There's, 100 different variations of Linux you can run on a Raspberry Pi, so on and so forth. So it is important to understand that this is actually a full-fledged computer. You can actually run a web browser, and I'll show you that in a future class. Not only can you use it as a server, but you can use it as a web browser. Again, you can use it as a desktop computer if you really wanted to. That is not the same as an Arduino. An Arduino is a microcontroller. What a microcontroller is basically just a simple IC chip. And what happens is basically you feed the Arduino code, and then all it does is it loops through that code infinitely. Normally what happens is you connect sensors to certain ports on the Arduino, and then you connect some kind of output basically physical device on other pins. So let's say you have a distance sensor. So I could connect a distance sensor to some pins, I could connect a little beeper to other pins, and then as something gets closer to the sensor, I can have the little beeper go beep, 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 right? Or I can have a water sensor. So I can have a water sensor connected to an Arduino. If that water sensor detects water, it can then trigger for a water pump to turn on and be able to pump out water. So it's very important to understand is when you're dealing with the Arduino, there is no operating system here. You're going to be using the Arduino IDE. You're going to be able to code for inputs. You're going to be able to code for outputs. You might be able to do some little bit more sophisticated things. You can actually now build very simple web servers using these Arduinos, but this is not a full-fledged operating system. You cannot plug this into a monitor monitor and actually, go to CNN.com or use a web browser or anything like this. This is a microcontroller. It's a different world. So think about this. If you're going to be creating sensors, if you want to create a specialized sensor suite, you would use an Arduino. Or if you need to trigger physical things to happen, to turn on HVAC systems, to turn on water pumps, to turn on those kind of environmental controls, that type of thing, and you want to create something very special, that is something that you might use an Arduino for. But an Arduino is a microcontroller. It's not a full-fledged computer. Well, then you're probably sitting there and you're looking at this and you're going, well, okay, well, this is a computer, right? It's obviously got a wireless on here. It's got the inputs, outputs on the backs. It's got the network. It's got the HDMI port, the whole 9 yards. So these must be the same. They're close. They're close. They're very similar. They're very similar. But again, they are not the same. The important difference between these two particular devices, so these are two computers, right? So I can plug this into a monitor, keyboard, mouse, and I can go to CNN.com. Same is true with the Raspberry Pi. I could set up a web server on this particular computer and use it for a web server. Same with the Raspberry Pi. So there are a lot of things here that are very, very similar. The difference, though, is that the Raspberry Pi uses something called an ARM processor. This particular mini PC uses an x86 processor. So when we start talking about CPUs, there are ARM processors and there are x86 processors. So when we talk about x86 processors, we're talking about things such as Intel, we're talking about AMD, basically any of those x86 clones. And this is the standard processor that most like normal desktops and servers would use. Xeon processors are x86 processors, Celeron processors are x86 processors, Atom processors are x86 processors, right? And so there's a special type of way that you have to code an operating system, and also you actually have to code the software to run on x86 processors. So the big thing to understand is that the Raspberry Pi uses an ARM processor, so you have to actually go out and get the operating systems and software that will run on ARM processors. So this is one of those things where you can run into problems, because you may be sitting there and with these little Raspberry Pis, you can get them all the way up to 8 gigs of RAM at this point. So you can have 8 gigs of RAM, it can have quad-core processor. So one of the things you might be thinking about is like, oh, well, why am I going to run my Active Directory server on some big server anymore? Let's say I had a 10-person company. And so instead of installing Windows Server onto a real server, hey, what if I installed that onto a Raspberry Pi? Well, the reason you will not be able to do that is because the Microsoft, the Windows Server operating system isn't built for ARM processors, so you simply would not be able to install that onto an ARM processor type computer regardless. And so that's one of the things that a lot of people run into, is they may be sitting there and they're like, oh, okay, so we have this big box in the corner. It's not under a tremendous load, so why don't I just transition that over to a little Raspberry Pi so I can just have this little device and it'll be providing very basic services to the network. One of the reasons you might not be able to do that is because this is an ARM processor, this is an x86 processor, so you may want to go down to a smaller x86 processor, but that doesn't necessarily mean you'll be able to go down to something like a Raspberry Pi. So these are close, but they're so close that it can run you into problems, because you just assume what you can do on this, you can do on this, and that is just not the case. This is an ARM processor, x86 processor, and this is an Arduino, which is just an entirely different world. So it is important to understand that this is not what a Raspberry Pi is. A Raspberry Pi is a full-fledged computer, but it uses an ARM processor instead of the x86. So now that we know what a Raspberry Pi is not, it's not an x86 processor, it's not an Arduino, now let's talk about what is required to actually set up a Raspberry Pi system. So obviously the first thing that you're going to need is the Raspberry Pi itself. There are a number of different versions of the Raspberry Pi. We'll talk about that in a little bit, but basically you're just going to need your Raspberry Pi board, and this is going to have most of what you're going to need for your project. So again, this particular board here, we have the network card, we have the USB connectors, we have 2 micro HDMI slots. This has the Wi-Fi built in, this has a Bluetooth built in, so on and so forth. So again, one of the important things to be thinking about when you go for the Raspberry Pi is the board that you're going to buy for your Raspberry Pi will have most of what you're going to need for whatever project that you're going to do. So in the Arduino world, many times you simply buy an Arduino, then you have to add a whole bunch of crap to that Arduino to make it do whatever you need it to do. with the Raspberry Pi, basically you buy the base board. That is going to give you most of the resources that you're going to require for your project, and then you add a couple of sensors, you add a couple of additional things on. So that's just one thing to keep in mind. So you have the board itself. Again, there are a number of different boards out there. We'll talk about that in a second. Past that, then you're going to need a micro SD card. So the storage for the Raspberry Pi is actually the micro SD card. And so what you're going to do is in a next class, we're going to show you how to install an operating system on the micro SD card. You then take that micro SD card, you simply slot it into the Raspberry Pi, and now you have a full-fledged computer. So basically this is the computer with the RAM, with the CPU, and then there is the storage. Beyond that, you are then going to need to think about getting a case. So just like any kind of computer, you need to think about getting a case for your computer. This is the standard Raspberry Pi case I simply got for these particular projects, but there are a lot of different cases out there. So just like if you're building a gaming computer, gaming system, you may buy a different case than you would for, let's say, a system that you're simply giving to a secretary in office. The same is true with the Raspberry Pi. So if I'm really going to be hammering the hell out of this little Raspberry Pi, I'm going to be making it really hot. So let's say I'm going to be doing things such as processing video files or something like that. Just like a normal computer, this will heat up based off of how much I'm actually using things like the processor. So if I have it in a case like this, that doesn't really have any air vents, that doesn't really have any fans or anything like that, then basically I'll probably run into issues with thermal throttling, where the Raspberry Pi will get so hot it will no longer be able to function properly, and then it may shut down, or I'll get quirks, or I'll get problems. So if I'm really going to just be grinding away with the Raspberry Pi, I may want to get a different type of case that may have additional fans on there to increase the airflow, maybe be a little bit bigger, so again have a little bit airflow there. If I'm going to be connecting things to my Raspberry Pi, I may want holes in the case that actually allow me to be able to connect to the GPIO pins in the Raspberry Pi from outside of the case. So one of the things you are going to need to be thinking about is the case that you're going to use for your specific projects. What will be the best case for your particular use case scenario? Simply going out and buying the cheapest little $8 case might not be the best way to go. So basically, we have the Raspberry Pi, we have the SD card, we have the case, and then we have the power supply. So for this particular Raspberry Pi, this Raspberry Pi is actually using a USB-C power supply. Again, depending on which particular Raspberry Pi you're using, you're just going to need to go out and grab whatever power supply your particular Raspberry Pi requires. Then past that, you're then going to need to connect this into a monitor. And so one of the things that's important to remember is, again, depending on what Raspberry Pi you're using, some Raspberry Pis have full-size HDMI ports. So you could simply plug a full-size HDMI cable into the Raspberry Pi, and then you don't really have to think about it. But with some Raspberry Pis, such as this one, this actually has a micro HDMI port to it. So basically I either need a micro to full-size HDMI cable. I actually have those. So one size is a micro HDMI cable and the other size is a full-size HDMI cable, or I would need a micro to full-size HDMI cable adapter. One of those things just to be thinking about. Again, that's one of the nasty little things in the real world where you can be sitting there and you can be thinking, oh, okay, I've got everything I need. I've got the case, I've got the SD card, I've got the power slot supply, I'm ready to go. And then you go to actually plug this into your monitor and it won't work. So this particular kit that I purchased this Raspberry Pi with came with this. And again, so this is a micro HDMI connector to a full-size HDMI cable. And so that is something that you may need. Beyond that, you can then also just simply plug in, whatever USB mice and keyboards you have lying around. So that's one thing I'll warn you. One of the ways that you can save money with the Raspberry Pi is don't buy the official mice and keyboards. So the Raspberry Pi uses the same standards for mice and keyboards as every other computer does. So you most likely have a few USB mice and keyboard laying around. So don't spend the extra, $20 or $50 for Raspberry Pi specific mice and keyboards, because literally whatever USB mice and keyboards you have lying around will work fine for you. So this is all that's basically required in order to set up the Raspberry Pi. This will allow you to use the Raspberry Pi as a desktop operating system. This will allow you to use the Raspberry Pi as a server operating system. And then future and additional classes, we'll talk more about the GPIOs and how you can connect things like sensors and that type of stuff to your Raspberry Pi. But this is the basics that's required for setup. So now that you know what a Raspberry Pi is not, what it is not, and you know the basic things that will be required in order to set up your Raspberry Pi, let's go over to the workbench so you can get a closer look at what this particular Raspberry Pi board looks like. This is a Raspberry Pi 4 Model B board. So again, there are different versions of the Raspberry Pi out there. I will show you this particular board, and then we will go to the computer, and I'll just kind of give you an overview of the different Raspberry Pis that are available so you have an idea of what you're dealing with when you're dealing with these boards. So with that, let's go over to the workbench, and I'll give you a closer look at this thing. So this is my particular Raspberry Pi board. Again, this is a Raspberry Pi 4 Model B. A lot of this will look the same, look similar to what you're used to with a normal computer, but some of this will be a little bit different. So let's just go and take a look at what is the same as a normal computer. So if we take a look here at the input outputs, we actually have a gigabit networking card here, so your gig networking. We have USB 3 here, so these are USB 3 ports, and this here are the USB 2 ports. So these are some of the inputs and outputs we have. Beyond that, we come down here. This is a simple audio output. So if you wanted to connect this to a speaker system, something like that, you could connect it there. Then here, these are where we have our 2 micro HDMI ports. So again, if we're going to be connecting an HDMI cable, you're either going to need a micro HDMI to full-size HDMI cable, or you're going to need an adapter like this. And basically here, all you do is you plug in, and now I can plug this into a full-size HDMI cable. So those are the micro HDMI cable slots. Then over here, this is where we have our USB-C power connector. So this is simply where we take our USB-C power supply, and we are going to connect that to this particular connector there. And so these are the standard connectors that you're used to dealing with almost any computer. Beyond that, we have some additional things here to be taking a look at. So up here, these are what are called your GPIO pins. These pins right here are one of the things that make Raspberry Pis really, 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 really cool. This is why I want to be dealing with the Raspberry Pi. Basically, with the GPIO pins, these pins allow you to do things such as connect external sensors, right? So just like with an Arduino, how I could connect something like an ultrasonic sensor to an Arduino and create a system, I can do things such as connecting ultrasonic sensors or water sensors or other types of sensors to these GPIO pins, and then based off of whatever the input is, I can write code in the Raspberry Pi to have events fire off. So basically with this, I can have sensors connected to the GPIO pins, and then I can also have basically the GPIO pins connected to physical events to have happen. So I could have the GPIO pins connected to servo motors. I could have the GPIO pins connected to relays. So if, let's say I had a water sensor, so if I had a water sensor, what I could have is if the water sensor detected water, then the Raspberry Pi could process what's going on, and then that could trigger that a water pump turn on, that type of thing. So these are the GPIO pins up here, and this is what makes Raspberry Pi, really cool and really interesting versus just simply being a small computer. Then beyond that, there's a couple of connectors here that we'll just go over. We'll deal with them in later projects. Right here is a camera connector. So again, one of the cool things, especially in the modern IoT world, is you can connect cameras directly to the Raspberry Pi. This weird little slot right here, there are a number of different cameras that have been created that will connect into this particular slot. So this is where you would connect your Raspberry Pi camera. And then here is actually a Raspberry Pi display connector. So think of this connector, if you've ever dealt with laptop screens, so how the laptop screen connects into the laptop motherboard, it uses a little ribbon connector much like this. And so the same is true with the Raspberry Pi. And so instead of connecting an HDMI screen, if you wanted to go with maybe a lower cost screen or a more specialized screen, you could actually connect that screen directly to this little ribbon connector right here. And so this is a basic overview of what the Raspberry Pi looks like. And then on the bottom, this is where we have our little storage. So this is where our little SD card goes. We simply slip that in there, and this is what we're going to be dealing with this particular. This is a Pi 4 Model B. So with that, let's go over to the computer so I can show you some of the different versions of the Raspberry Pi so you have an idea of what else is also available for you. So here we are at my demonstration system. I just want to take a look at some of the different Raspberry Pi boards that are available. Again, at this point, there are a number of different Raspberry Pi boards that you might find in the wild, and obviously they continuously create new boards. So the board that we're going to be dealing with for many of our projects are going to be the Raspberry Pi 4 Model B, but if we scroll down, we can see that there are numerous other different boards out there. So we have the Pi 3 Model A+, Pi 3B+, Pi 3B, Pi 2B, Pi 1B+, so on and so forth. And if you can take a look, not only is there a difference with simply like what the RAM is or what the processor is, but there's also physical differences. So with the Raspberry Pi 3 Model A+, as you can see, that actually has a full-size HDMI connector. So this is going to be a very important thing to be thinking about with the Raspberry Pi is what your particular use case is, because in your particular use case, it might be far more important for you to have a full-size HDMI connector than it does to have something like USB 3. Right? And so when you're sitting there and you're thinking about what Raspberry Pi to buy, you may find that actually buying an older version of Raspberry Pi for your particular situation might work out better for you. If we go over and we take a look again at the Raspberry Pi that we're dealing with, so this is the Raspberry Pi 4. Again, I've got the B version. We go over and take a look at the tech specs, and we can see what this thing has. So it has a quad-core 1.5 gigahertz processor. So again, ARM. Just so that's reiterated, this is an ARM processor, but it is a quad-core 1.5 gigahertz processor. You can get in 2, 4, or 8 gigs of RAM. So again, if you have like RAM-intensive tasks, you may want to go for that higher-end RAM. If you don't have higher RAM-intensive tasks, you may want to go for the lower-end RAM. One of the important things to be thinking about when you buy the Raspberry Pi is it's very much like speccing out a server or speccing out a desktop operating system or a desktop computer. Think about what the situation is. Think about what the resources will be that are going to be required for your particular project, and then buy the particular Raspberry Pi that suits that particular situation. So whether you need a 2 gig or an 8 gig, that really depends on what you're going to be running on the Raspberry Pi. Beyond that, we have the Wi-Fi. Again, for this particular version, we actually have AC wireless, and then we have Bluetooth 5.0 with Bluetooth low energy. So again, depending on your particular project, having AC wireless and Bluetooth low energy, that might be a valuable thing, or maybe not. Gigabit Ethernet, 2 USB 3.0 ports and 2 USB 2.0 ports. We have the GPIO header. So this is the full 40-pin GPIO header. So different Raspberry Pi boards may have different sized headers. So basically that's a number of those GPIO pins. So just one of those things to keep in mind. 2 micro HDMI ports. Then this is the display port that I showed you, and this is the camera port, the special ports that I showed you. Stereo audio coming out. Has the codecs built in, has a micro SD slot, 5-volt DC via USB-C, and power over Ethernet enabled. It requires an additional PoE hat. So these are some of the things to be thinking about with this particular board. If we go over, we can take a look at, let's say, the Raspberry Pi 3 Model B. So this is an older version, but here again you got that full-size HDMI port, so that might be valuable for you. We can scroll down. We can see this is a quad-core 1.2 gigahertz processor. This only has 1 gig of RAM. It has a wireless LAN, so I think this is like only N or something LAN. It only has 100 T100. Ethernet has 40-pin GPIO, and it has some of this other stuff down here. So again, it's just important to understand that there's different hardware depending on the different board that you buy. Then we can go all the way down to the Raspberry Pi 0W. So this is the smallest Raspberry Pi that they create, but this particular one actually also has a wireless built in. So we can take a look at this, and if we scroll down, we can see that it has ABGN wireless LAN. It has Bluetooth 4.1, also has Bluetooth low energy. It's a 1 gigahertz processor with 512 megs of RAM, so on and so forth. So again, this just gives you an idea of the different Raspberry Pis that are available. One of the nice things about these smaller Raspberry Pis, so if you go with the 0 or the 0W, is the price on this is frickin' wonderful. So something with a full Wi-Fi stack that you can actually run an operating system on, the whole 9 yards, this thing only cost $15. right? This costs $15, and if you get the Raspberry Pi Zero without wireless, that is only $10. So for $10, you can get a full-fledged, an actual computer, again, to run very basic desktop operating system or a very basic server. And so that's something that you may want to think about. So if we look at this, you know, the Pi 4 Model B, this is really cool and sexy, but I think this is like $45 or $50. If you just buy the board itself, it's $45 or $50. And for that, you know, you get gigabit Ethernet, you get 802.11ac, you get a lot of hardware here. You know, again, we go down to the Zero W. This only costs you $15, also gives you wireless, but obviously doesn't give you as much processing or RAM. So again, depending on your particular situation, it will really depend on which one of these you use. So that's a base overview of what these look like physically. So now that you're getting a better idea of what the Raspberry Pi is, I want to talk about the GPIO pins. So I would argue the GPIO pins are what make the Raspberry Pi a really cool little product. So at this point in time, there are a crap ton of small, inexpensive, power-efficient computers out there that you can use to create desktop computers or servers or the whole 9 yards. What really makes the Raspberry Pi interesting is these GPIO headers. So with these GPIO headers, again, just like when you're dealing with the Arduino, what you can do is you can connect external modules and devices to those GPIO headers and then trigger things to happen. So again, I can connect an actual, this is an ultrasonic distance sensor, so I can actually connect this ultrasonic distance sensor to this Raspberry Pi through the GPIO headers, and then, you know, if something comes too close to the Raspberry Pi, I could trigger a physical event to happen. So basically, maybe if something gets too close to the Raspberry Pi, I could turn a light on, or I could you know, have some kind of alert warning sound trigger, something like that. So that's what makes this pretty cool. You can add water sensors, you can add distance sensors, temperature sensors, all the kinds of sensors that we worked with before with the Arduino. You can add all those types of sensors and actually more to the Raspberry Pi, and then with your code you can trigger what'll happen based off of what the sensor readings are. But once you start dealing with these GPIO sensors, this does get a little bit more complex, and it is a little bit more confusing than the Arduino world. The first thing that you do have to remember is when you're dealing with the Raspberry Pi, you are dealing with a full-fledged computer. So you're going to be interacting with the GPIO pins through the programming language of your choice. Generally, especially when you're starting in the Raspberry Pi world, it's going to be using the Python programming language. So when you code for the Raspberry Pi, you can be coding in Python, you can be coding in PHP, you can be coding in Node.js. So most likely, whatever coding language you're already comfortable with, if you're used to a server-side coding language, that coding language will most likely work on the Raspberry Pi. Then what you do is you use libraries, so GPIO libraries for whatever particular programming language you're using to actually be able to interact with the GPIO pins. So if you're using Python, there's a built-in library called the GPIO 0 library, and so through Python, you're able to call that library and you're able to interact with the pins. The same is true, they have a library for PHP, so you can go and do a Google search for the library for PHP to be able to interact with the GPIO pins. Node.js has a library for connecting to the GPIO pins, so on and so forth. So one of the important things for interacting with the GPIO pins is you're going to be using a standard programming language, most likely Python. You'll be using Python, you'll be using the GPIO library, and with that library, you'll be able to write the code to be able to read from the pins and then actually send outputs to the pins as need be. One of the big issues that you will see, though, with the Raspberry Pi world is that there are 40 pins here, and there's no writing. There is no cheat sheet actually built onto the board itself, so it can be a little bit difficult to know what pin that you're supposed to be connected to. So let's go over to the computer so I can show you what the pin layout is, so you have a better idea of how you'd be connecting your devices to your Raspberry Pi. So here we are at the Raspberry Pi website. So again, this is just at raspberrypi.org, and we're going to the usage of the GPIO pins, and this will kind of give you an idea of these different GPIO pins. This is something, you know, if you've been getting a little bit older and you've been wondering whether or not you should buy reading glasses, this might be the time to buy reading glasses. One of the things I do dislike about the Raspberry Pi is it's a little bit difficult making sure you're connecting to the proper pin, and they haven't done you any favors by by this pin layout. So basically, when you're taking a look at the board this way, this is the pin diagram, the pin labeling for what these different pins are. So you can see on the top left-hand side, you have the 3.3 volt power. Then under that, you have the GPIO 2 and GPIO 3 for SDA, also SDA and SCL. You will remember those from the Arduino world. Then you have GPIO 4. Then you have ground. Then you have GPIO 17, 27, 22. Then you have a 3.3 volt. Then you have 10. Then you have 9. Then you have 11. Then you have a ground. Then you have a 0. Then you have a 5. Then you have a 6. Then you have a 13. Then you have a 19. Then you have a 26. And then you have a ground. You go over to the other side. You have two 5 volts. Then you have a ground. Then you have 14, 15, 18 ground. 23, 24 ground. 25. 8, 7, 1 ground, 12 ground, 16, 20, 21. And so, yeah. So if you have any problems with your Raspberry Pi projects, if you're sitting there and you just cannot figure out why your sensor is not working properly, it's probably because you plugged it into the wrong little connector on this GPIO output. Again, I don't know what the hell is going on here. It's just, you just look at how this is diagrammed out, and this is a complete mess. But as with many things in the technology world, just because it's a complete mess and looks stupid doesn't mean you can do anything about it, right? This is how the pins are set up, and so you've just got to grab your reading glasses or your magnifying glass. Make sure you count properly. Oh, was that supposed to be the 5th pin down or the 6th pin down? And then connect everything up. So these are the different GPIO pins, and so you will be using this chart or a chart like it a lot when you're actually building out the Raspberry Pi IoT projects. Again, just simply to make sure that you're connecting to the correct pins. And if you're looking at this thinking, my golly, this is stupid, don't worry, you're not the only one. It's very curious with a pinout. Past that, we can go down and we can see some different information. So they talk about the voltages, they talk about inputs and outputs and that type of thing. So we learn a little bit more about that. You can learn about that here. They also show that RASP-IO, that I guess some of the Raspberry Pi boards, you can actually get this little template to show you what the different GPIO pins are, which, yeah. Anyways, past that, I just did want to show you, this is the GPIO 0 library. So again, in order to be able to communicate with the GPIO pins, whether it's input or output, you will need a library for your programming language. The GPIO library comes with the Raspberry Pi operating system. So when you install the Raspberry Pi operating system, the GPIO 0 library is already installed. This is for the Python programming language. So if you want to use PHP or Node.js, go and do a Google search on that, but the GPIO library is just for Python. And just to come down here, I just want to give you an idea of what the coding in Python looks like when you're dealing with the GPIO pins. So this is where you're going to be importing the libraries for Python. So from GPIO 0, you're going to import LED. From time, you're going to import the function for sleep. Then this is where we actually create the LED. So the LED is going to be connected to pin 7, GPIO pin 7. And then this is just a continuous loop. And so basically all this particular code is doing is making a blinking LED. So it's going to turn the LED on. So this is the LED at GPIO 7. Then it's going to sleep for 1 second, LED off, sleep for 1 second, and loop, 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 loop. If you go through here, again, you can see some different things, so garden, we have an LED, we can have a motion sensor connected to GPIO 4, we have a light sensor connected to GPIO 5, and then we can create code based off of what's coming in from those different sensors. We will talk about this in classes going forward, but I kind of did just want to give you this overview to realize dealing with the GPIO pins is not some, insanely complicated thing. You just do have to understand what pins to connect to, and then whatever library you're going to be using to connect to those pins, you'll use what's ever required with that library. So this is basically what those GPIO pins look like, and more or less how you're going to be interacting with them. Now, as far as the GPIO pins and add-ons are concerned, you can do more than simply connecting basic sensors and basic outputs. You can also connect more complicated boards to your Raspberry Pi. In the Raspberry Pi world, these are called hats. So in the Arduino world, you may connect a shield to your Arduino. So let's say a data logging shield or a Wi-Fi shield or a network shield. In the Raspberry Pi world, this would be called a hat. And think about it in a computer, reference. Think about it as an additional, basically something like a PCIe card that you would slot onto your Raspberry Pi to give a lot of additional functionality. If we go over to the computer for a second, I can show you some of the options are available. Whether or not you will actually use hats in the real world really depends on your particular projects. Just realize basically what the hats are is they're like additional add-on cards for the Raspberry Pi that generally will provide a lot more complicated resources to your Raspberry Pi project than simply basic digital or analog sensors. So let's go over to the computer for 1 second just to show you a couple of these hats so you have an idea of what's going on there. So if you go to the Raspberry Pi website, you can scroll down. I've shown you the boards, but if we keep scrolling down, we can see a couple of the hats that are available from Raspberry Pi. Just like on the Arduino world, there are a lot of other vendors out there that manufacture hats for Raspberry Pis. So if you're looking for a hat to do a specific function, go do a Google search. Adafruit may be creating one. Some other third-party vendor may be creating the hat that you're looking for. Don't think that these are the only hats. So you can see here we actually have like a TV hat. We have a POE hat, and we have this little Sense hat, and these are the ones that Raspberry Pi themselves are building and selling. If we go over and we take a look at like the Raspberry Pi POE hat, so as I showed you in the documentation, the Raspberry Pi 4 Model B that I have actually can support power over Ethernet. So if I wanted this to be powered over an Ethernet cable, I could simply plug the Ethernet cable in, but to make that work, I would need the POE hat to be actually able to process that power. And so this is that particular hat. So we can go through, we can take a look. It tells you what hardware is needed for this particular hat to work, so on and so forth. If we go over, we can take a look at the TV hat. So if you wanted to actually be able to bring TV into your Raspberry Pi for some reason, let's say this is for like some kind of surveillance application, something like that, you can use the Raspberry Pi TV hat to do that. We can go and we can take a look here. And basically, as you can see, the little hat basically slots on all of those GPIO pins, and they're able to connect the TV cable here. We can go down, we can take a look and see what information is required in order to make this particular hat work. And then we can go over and we can take a look at the Sense hat. So the Sense hat is actually pretty interesting. And again, depending on what particular project that you're doing, something like this may be valuable for you. So instead of adding on a number of additional little external sensors, it might be better to simply add a hat that has a number of those sensors already built into it. So for this particular hat, the Sense hat, it has a gyroscope built in, an accelerometer built in, a magnetometer built in, a temperature sensor built in, a barometric pressure system sensor built in, and a humidity sensor built in. So imagine if I'm going to be creating some kind of environmental control Raspberry Pi device, instead of adding and wiring all of these individual sensors to my project, it might be better to simply buy this one particular hat that has all the sensors I need. Then I can simply interact with those sensors. There's less opportunity for wires to get pulled out or to have little problems, little quirks with failure. So this is an overview of some of the hats. We'll deal with these in classes going forward, but this just does go to show you not only can you be connecting individual sensors, but just like with a normal computer or with an Arduino, you can add on a full, basically additional expansion card to give you a lot of other functionality for your Raspberry Pi projects. So now that you know what's going on with the hardware of the Raspberry Pi, now we just need to talk about the operating system that you're going to be using on your Raspberry Pi. So again, to be clear, this is a full-fledged computer. It just happens to use an ARM processor. There are a lot of different operating systems that are available for the Raspberry Pi, and so what you decide to use really is up to you, your situation, your preferences, so on and so forth. When I do the Raspberry Pi classes, I'm basically going to be sticking to the Raspberry Pi OS. So basically they have a distribution of Linux that they've tweaked to work properly on the Raspberry Pi, and then I will also be doing classes using Ubuntu. So there's a version of Ubuntu that will work on Raspberry Pi. I'm one of those people that believes in consistency. So most of the time when I'm showing you how to do different things with Linux across the board, I'm showing you how to do that in Ubuntu. For me, I have just picked Ubuntu as my default standard for the Linux distributions. And so basically when I'm doing the Raspberry Pi classes, when I'm doing the introductory level Raspberry Pi classes, I'll be using the Raspberry Pi OS, the distribution specifically built for the Raspberry Pi. But then as we go on and we start doing more complicated things, basically building out more projects that would be in more of like an infrastructure type environment, that is when I will switch over to Ubuntu, because again, I've already done many classes showing you how to use Ubuntu. And so if you already know the commands and standard Ubuntu that you use on a desktop or laptop, the same commands hold true with the Raspberry Pi. So if you're already familiar with Ubuntu, I can bring you over to Ubuntu on Raspberry Pi, show you a couple of additional things, again, how to interact with the GPIOs and that type of thing. But the knowledge base that you already have in Ubuntu will translate over to the Raspberry Pi. This is something to be thinking about, again, with the operating system that you decide to use. If you're a hacker, right? They've got a Kali version that you can put on the Raspberry Pi. If you're in the Windows world, so you're using Active Directory and that type of thing, there is actually an IoT version of Windows 10. You can put that onto Raspberry Pi. Again, there are a lot of different flavors and versions of operating systems that you can put on the Raspberry Pi. What you decide to put on the Raspberry Pi depends on your particular situation. I'm going to be showing you the Raspberry Pi OS just because like that's the default standard. It's pretty easy to show new people, and then when I start getting to be into more complicated things, I'll show you how to do that using Ubuntu. Simply, that is my preference. What you decide to do in your environment really is up to you. So let's go over to the computer. I will show you kind of like the standard distributions that they suggest for the Raspberry Pi, and then we can go over and I'll just show you there's like a list of 20 other of the current best distributions that you can use, just to kind of give you the idea that there are a lot of different operating systems that you can use, and so what you decide to pick really is up to you. So with that, let's go over to the computer and show you what different operating systems are available. So here we are back at raspberrypi.org in the download section, and this is where I can just show you some of like the official operating system that Raspberry Pi gives a thumbs up to. Obviously there's the Raspberry Pi OS, so this is the version of Linux, a distribution of Linux that has been specially basically tweaked in order to work with the Raspberry Pi. Again, I will be showing you a lot with this particular operating system just because it's the default standard. It's not particularly like a great operating system or anything, but it's kind of the standard everybody starts with. So you can go with the Raspberry Pi OS. If we scroll down, we can see that they do have some other third-party operating systems here. And that, again, these are the kind of, I don't want to say that they're the approved ones, but basically people feel pretty comfortable about using these on the Raspberry Pi. We have the Ubuntu version, so Ubuntu Mate, the desktop, Ubuntu Core, Ubuntu Server. They have OSMC, an open source media center, Libre Elec, Mozilla Web Things, PiNet, Risk OS, and those are some of the operating systems that basically give that the Raspberry Pi is more or less giving it the thumbs up to. But if we go over, we can take a look and we can see that, again, there are a lot of different operating systems that are available. So I simply did a Google search, and this is the 20 best Raspberry Pi OSs available in 2020. Again, it depends on what you particularly think. But if we come down here, we can see that there's Raspbian. If you want to use that, we can see Diet Pi. We can see Libre Elec that we saw up there, OSMC, Risk OS, Windows IoT Core. So again, if you needed a variation of Windows for the Raspberry Pi, again, the IoT Core is not like a desktop version of Windows. We'll talk about that later. Laka. But basically you can scroll through here and you can just see that there are a whole bunch of different distributions and versions of operating systems that you can use on the Raspberry Pi, and again, even including Kali Linux. I know I've got the hackers out there. I can't get rid of them. No matter how much I laugh at them, no matter how much I tell them to go away, I know I've always got the hackers watching these. So if you want Kali Linux on your Raspberry Pi, they do have a version of Kali Linux for your Raspberry Pi, and you can just go through, and again, like I say, there's lots and lots of different distributions. What you particularly decide really is up to you. We can go over, and I did just want to show you This is actually at Windows, the Microsoft website, so docs.microsoft.com. And again, they show you setting up a Raspberry Pi. So this is how to use something called the Windows IoT Core. So again, this isn't standard Windows. To be clear, it's not standard Windows. It's an IoT version of Windows. But again, if you need to interact possibly with Active Directory, if you need to interact with the Windows stack or the Microsoft stack for some reason, you may want to go with Windows versus a version of Linux. And so this is showing you how to actually install this version of Windows onto your Raspberry Pi. So these are just some of the different OSs that are available for you. Again, I'm going to be showing you the Raspberry Pi OS, and then we're going to be working with Ubuntu. That's just what I default to. What you decide to do is, really up to whatever your choices are. So there you go. Now you have a brief overview of what a Raspberry Pi is, why you should be interested in the Raspberry Pi, and the basics of what will be required in order to make the Raspberry Pi function. Again, I'm very excited about the Raspberry Pi because essentially what you get out of the Raspberry Pi is you get all the computer functionality of a computer. So you get an operating system, you get your coding languages, whether it's Python or PHP or Node.js or anything like that. You get what you're used to interacting with, but then you also get the ability to interact with those GPIO pins, so you can do things such as connecting sensors, you can connect hats, so on and so forth. So basically, I really do think the Raspberry Pi is a nifty, neat little technology device in the modern world, and I think is probably something that you may really want to think about adding to your infrastructure. One of the great things about the Raspberry Pis too is that they are shockingly inexpensive. Again, until I started working on them, I really thought that they're going to be a little bit more expensive than they are, especially dealing with the Arduino world. But when you look at the Raspberry Pi Zero, so the Zero without wireless, so if you wanted to connect to sensors or things like that, that's only $10. So you buy that, you buy an SD card, you buy the power supply and all that, and for a very, very low cost, you can have a computer-based, sensor or some kind of, output, something like that. That's a pretty cool thing. Again, the Raspberry Pi Zero W, so that actually comes with a full Wi-Fi stack, that's only $15. And then you get up to the Raspberry Pi 4s and above, and then you can get like 2 gigs of RAM or 4 gigs of RAM or all the way up to 8 gigs of RAM. Again, this thing has 8 gigs of RAM, it has a quad-core processor, it has 802.11ac, Bluetooth 5, Bluetooth low energy, the whole 9 yards. You get all of those resources in a relatively inexpensive, small, power-efficient package. That's pretty interesting in this modern world. So I'm going to be very excited to continue teaching you about the Raspberry Pi. I think there's a lot of things you can do with the Raspberry Pi, especially if you start opening your mind. And again, in the modern world, in the IoT world, you need to start thinking about computers in relations other than simply, desktops and servers. So for so long, you had a desktop and then you had a server. And then we went to the cloud. And so then you had like a desktop and then you connected to something on the cloud. One of the things I want you to be thinking about is, what if you could have the power of a computer for $15? You could connect all of these devices. You can do all this processing, again, intelligence at the edge. So basically at the edge of your infrastructure with sensors and all that kind of thing. What if you could do a lot of interesting things? And basically, instead of having 100 client computers that connect back to one server, what if you could have 1,000 sensors? Or 1,000 devices all bringing in information about your environment, and then thinking about how you would process that information, how you would parse that information, what you would do with that information once you've gotten results. I think that's where we start to get to some very, very, very interesting things with the modern world of IoT. So I'm looking very forward to continuing this track. As always, I enjoy doing this class. Look forward to seeing you on the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.